Okay. Good morning and welcome to another day of living. Woo! Another day of love. Okay. So we're going to start where we left off yesterday with the we just finished off with the uterine cycle or the menstrual cycle. And so we're going to, we took a look at this, whoops. And, all right. And then now we want to go on to why else is it important for women to have estrogen and progesterone. So these are going to be the things that happen during puberty. As the estrogen is beginning to be secreted in large enough amounts to start having an effect on its target cells, that's what's going to happen. So we'll get oogenesis and follicle growth, along with the FSH that's being produced by the anterior pituitary, acts on the follicle. We also need to have the estrogen there as well. Maturation of the reproductive tract, again, just like in the male when testosterone was being secreted during puberty, we also need that in the female so that the uterus and the uterine tubes and everything can grow to the adequate size to house a baby. Because what else is a uterus for but to receive the fertilized ovum and to allow it to implant and then take care of that baby until it's time for it to be born. The third thing is the growth spurt. Remember, we have synergistic effects with growth hormone and the androgens, so testosterone and estrogen during puberty. So we've got that fairly steady growth curve up until puberty, and then we get that extra little boost of growth to help the individual attain adult size and stature. As far as the whole body is concerned, you need to be big enough to not only do the reproductive structures need to be big enough to accommodate carrying that baby and being able to deliver the sperm to the woman's body, but we also need to be big enough to take care of our infants. We can't stay child-sized and care for an infant because it's not going to work as well. Being able to not just care for our offspring, but be able to protect our offspring, go out and hunt and go out and find food and construct shelter and care for the other siblings. And, you know, there's a lot of work to do as a grown-up, and you need to be big to do that. So when the estrogen starts to be secreted, then it's going to go to the growth plates and have a stimulatory effect on the cartilage cells, the chondroblasts there. And so that's going to happen in a female a little bit earlier, a couple of years earlier than it does in a male. And that's why you typically see in 6th grade class pictures, the girls are taller than the boys, because the girls are going to shoot up first and then the boys are going to follow them within a couple of years, and then of course exceed them in a lot of cases. But that's so they'll grow sooner than boys, but then they'll also stop growing sooner than boys. And so with Amy, and being as tiny as she was for such a long time, that we needed to make sure that her growth plates hadn't fused. And you know, of course, she doesn't get any growth genes, you know, any height genes from me and my side of the family. So she was already destined to be short anyway, but she was short. And it was only until last year, I guess it was, that I mentioned to you that the orthopedic surgeon had said, oh, it looks like your growth plates are fused and you're done growing. And so she's really mad about that, but she looks fine now. She stands with the rest of us and she's all the same height. So it's all good. Plus she's a flyer. You need to be tiny when you're a flyer. All right. And then lastly, this also has to do with being a mommy. So growth of breasts, subcutaneous fat, widening of the pelvis, axillary pubic hair. And these next two are great benefits that females have with their estrogen. So we have low blood cholesterol since we have high HDLs. Like I mentioned before when we were talking about cardiovascular system, You rarely hear about a woman having a heart attack premenopausal, and rarely ever before 50 do you hear about women having heart attacks. And then they'll have them after that because we stop producing the estrogen, and then our HDL levels will drop. And so that's a bummer. But the calcium uptake, I'll also talk to you about that, how estrogen inhibits osteoclast activity. And because the funny thing is that PTH and your parathyroid glands are really always trying to make sure that you have calcium in your bloodstream, which it should do. And if we're not eating enough, then they're going to take it out of our bones. And so we need to, during our reproductive years, make sure that our bones do not become osteoporotic or even osteopenia, like a low level of like thinning, or lack of. And because we need to have super good bones, calcium in our bones, because that's where all our baby skeletons are going to get their calcium from. So imagine you have 6, 7, 8, 9, 10, more than that worth of kids. You better hope that you've got adequate amounts of calcium in your bones to be able to nourish that many fetal skeletons. Okay, so there's that. All right, now as far as pregnancy is concerned, it's from the start of the last menstrual period until birth is 280 days. I know that's more like 10 months. I know when you're pregnant, it feels like an eternity, but the first 2 weeks, the first 14 days of this 280 days are nothing, because you can't even get pregnant. So all we can do is go with when your last menstrual period was, and then we count forward 280 days, and then you should be good to go as far as when your baby should be due. So notice this, because we don't know in most cases when you got pregnant, the day that you got pregnant, and then babies come early, babies come late. So we just need to have an idea of when you're going to have a baby, instead of saying, okay, you're going to deliver on your due date, because you're not going to deliver on your due date probably. I never ever went into pregnancy. I never went into labor ever on my own. My babies would have stayed inside of me forever. They just did not want to leave, and we had to evict them. And so for me, I don't know. It's weird. I don't know if I ever would have gone into labor on my own. Won't ever know that. All right. So for those of you that stuck around yesterday, Erin and I had a little conversation about this next bullet point, being able to determine the gender of your baby, or decide the gender of your baby. Obviously you can do it through embryo manipulation. You can get it, in vitro fertilization. You can get a Y-bearing sperm and fertilize an ovum, or a X-bearing sperm, depending on what you want. But if you just want to do it regularly, it may work, it may not work. So this is just I don't know. It's not going to be on the test. So we do know this part you do need to know, that the oocyte is only viable for 12 to 24 hours after ovulation. So there's only one day that you can actually get pregnant. Now, you could have intercourse multiple days, but there's only one out of those days where the ovum and the sperm actually met. And so, so that's why we're like, well, I don't know when you got pregnant, because, we were having intercourse all the time. And so it could have been any one of those days, but no, it's just the day that you ovulate. Sperm, however, and actually something we were talking about in my embryology classes, that sperm can even last up to 5 days in the woman's body, instead of just the 3 that I have here. So sperm are pretty sturdy creatures. And but here's what you would do if you wanted a girl and if you wanted to have a boy. So I didn't put the ideas behind this. So the idea is that X-bearing sperm, those that are going to create girls, are swim slower but last longer. So you want to make sure that ovulation happens first, and then you have intercourse, so that no, that's a boy. You want to have intercourse first, and then ovulate, so that the only sperm that are there are the girl sperm, okay, the X-bearing sperm. But if you want a boy, then you want to ovulate, and then you want to have intercourse, so that the fastest sperm will get to the ovum first, which should be the Y-bearing sperm. But who knows? I mean, you look at families that have all boys or all girls. I have a nephew. They just had their COVID-19 baby in isolation about a month ago, and they only have boys. When Carly was pregnant with the last, and they found out what their baby was, and she was a little sad because they have 3 boys, and so now she has 4 boys. But she's a boy mom, so she gets it. And then there are, of course, girl dads that have all girls, and they're perfectly fine with that. So I wanted all boys, but I got a mixture, so I'm happy with that. I'm happy I have children.
I wanted all boys.
Huh?
I wanted all boys, and
Yeah.
I got 2 girls.
I just wanted a basketball team, and well, actually, I wanted a baseball team. I didn't really want 9 boys, but I did want a baseball team. So I guess I wanted about 5, and then we could find 4 others to come and play ball with us. But okay. So the other thing, though, that you need to remember is this right here. Fertilization occurs a third of the way down the uterine tube and forms a zygote. Okay, so let's just where's my little, so I'm just going to underline the things that you need to know. Okay, so oocyte viable for 24 hours after ovulation. Yeah, I don't care that you remember. We all know it's 9 months, but after, so the start of the last menstrual period, and then fertilization occurs a third of the way down the uterine tube and forms a zygote. And we talked about that in our lab presentation the other day, why that has to happen. Why it has to be clear up high in the uterine tube and again, we're going to talk about that today. So, okay, let's look at this picture, this next image, and then we're going to put when we'll go back to that chart that has everything stacked up, and then we'll just draw lines and see where everything all goes together. So this is good. This has the 3 phases. Well, it has 2 phases. Anyway, it has the ovarian cycle and the uterine cycle. It doesn't have the hormonal stuff, and that's why our chart is good, because it does have the hormonal things on top. So this has been lined up. So here you can see the uterine cycle is divided into 3 phases: menstrual phase, proliferative phase, secretory phase. Here we're losing, if we take a look at what is functionalis, what is basalis, here is that constant basalis thickness right there, the darker color. And then here is that varying thickness of the functionalis. So here we're at the end of our menstrual cycle, and our uterine lining is as low as it's going to be. Then when the FSH and, well, anyway, FSH and LH are coming, now we're getting primary follicle, secondary follicle here happening now through the proliferative phase. We're getting one of those follicles ready to ovulate, and we're thickening the endometrium in preparation to receive this ovulated fertilized ovum. Then ovulation happens, and so now we want to make sure we built the room. Now we want to make it nice and pretty, and paint the walls and put pictures on the walls, and make the bed, and I don't know, whatever stuff that you're doing in that room for the potential tenant to move in. So that's all the secretory phase, and the secretory phase is governed by the progesterone that's secreted from the corpus luteum. Okay, so let's just go ahead and go to that chart so we can line everything all up hormonally, as well as okay, as well as what's going on in the uterus and the ovary. Okay. I'll come over here. I'll stop sharing because I don't even know what you can see. There we go. Boom. All right. So here is what I want to look at. And yeah, we'll just go like that. Okay. Let me get my draw. Oops. I don't want that. Oh, oops. What am I doing? Oh, you guys. I don't know what I'm doing. There we go. Oh, I know what I did. I hit on stop share. Okay. All right. So let's talk about everything that's happening. So let's draw this line up here. Okay. So during the menses, we're going to have, so just prior, so day one. Okay, here are our gonadotropin hormones. They're going to be just being secreted. We can see some little peak things going on right here. We can see that these two, estrogen, progesterone, are the lowest they're going to be in a month. Okay, until we come back to this time period over here. And then if we look at what's happening here in the follicles, so this FSH is acting on these, and we call pre-ovulatory or follicular phase. Follicular. So make sure you remember this is the follicular phase because that's what we're focusing on. We're making follicles. You know, this is lame there calling it pre-ovulatory, post-ovulatory. They have names, for crying out loud. All right. So now this little peak in here, this little bump in estrogen is because these cells here on the outside, which are called the theca folliculi, or just the thecal cells, they are now starting to produce estrogen. And so we're going to get this little bit of surge, and then we're just going to keep getting it higher and higher and higher. Now notice right here, day 7, definitely by day 10, let's put day 10 in there, 7/14, so that's, let's do it right up here. Okay, so if we look at our levels right here, holy cow, look at what happened to FSH. Man, that sucker dropped, so this is going to be about day 10. Okay, LH has remained pretty level, as low as it's going to be in a month, okay? And so it doesn't really change, but FSH drops off because of the inhibitory effects of this estrogen right here. Okay, so this estrogen point right here is up to, you know, all of this right here is all inhibitory on the gonadotropins. And this is just continuing its development even in the absence of the estrogen. It's, I mean, FSH, it still has estrogen around here that is helping it move along into the last, to ovulation, get it ready to ovulate. All right, so notice, so here's day 14, but we want this day right here, day 13, is where we're going to get this LH surge and this FSH surge. Okay, so both of these surges are going to happen 24 hours before ovulation, and now that's due to this. Okay, so now I have a positive feedback release on LH and FSH by this high amount of estrogen that now I'm going to, so this is going to be like day 12, super high, day 13. So we're just, you know, it's hard to pinpoint an actual time period and say, okay, now this happened. But it's going to precede just before the LH-FSH surge, and then the LH-FSH surge is going to cause ovulation. But if we look down here, so all of what's going on here, well, actually, let's go on. What's going on there? Okay, look it. I have none of these guys. Not enough of these guys. So because I have very little of my ovarian hormones, I'm going to lose my uterine lining. And this uterine lining here was from the cycle that happened back over here, the previous cycle. So now, as I go into my new cycle, as my estrogen levels are climbing, here is what's happening to my endometrium. It's thickening my functionalis layer. Then I get to day 14, and so now this is just going to plummet, and then these are going to stay pretty low. And if we look at right here, now they're super low, and if we come down to super low, oh goodness sakes, look at that. Okay, so as these are declining because we're not increasing concentration any, then this doesn't have a signal anymore to continue to produce progesterone. So here we're in our luteal phase. And then that's going to be due to the presence of LH, but it's going to make progesterone and estrogen too. Oh, that was bad. Progesterone. Okay, so here you can see now that I have a corpus luteum, look at what my progesterone levels are. Ooh, just up here. And then I had that drop off because then we had to wait for the corpus luteum to start producing estrogen, because now my fecal cells are not producing it over here. And so then we went up, but we don't need it as much. Progesterone is the thing that we need right here so that we can secrete the uterine glands, make the uterine glands and the spiral arteries. So that's what these purple things are, uterine glands, and then the spiral arteries that are in there. Okay, I guess that's about all. I've marked up the picture pretty good, but hope that you now have an understanding of all of the things that are going on. So just make sure that you can say, okay, when this is happening, and this is happening too. And it's all because of why. I mean, why are all those things happening? Because they're all related to one another. They all have to happen in that same manner in order for us to have a baby. So really having a baby is amazing that we even get pregnant. And then it's, okay, first of all, it's amazing that we produce gametes. Then it's amazing that our gametes meet. And then it's amazing that our baby can grow to be deliverable, and then it's amazing that they grow up to be adults and have their own children. And I mean, just everything is absolutely amazing. So life finds a way. It's a beautiful thing. Okay, so does anybody have any questions before we go into embryology now? Sweet. Okay, so I'm gonna get out of this and put that down there. Go back to my PowerPoint. Okay.
Miss G, didn't you say that progesterone is what we need in order to keep the baby? Is that correct?
Well, it's to maintain the uterine lining. I mean, it has nothing to do with the baby itself.
Okay.
It's just to make sure that that we don't start a period while we're pregnant.
Okay.
Yeah.
Okay.
Yeah. So progesterone, and maybe I didn't make that clear, but I will as we get into fertilization here. Yeah. Progesterone from the mom doesn't have any effect on the baby whatsoever. It's just for the mom to make sure that she stays pregnant.
Okay. Thank you.
Yep. Okay. The next slides that are in here are also going to be in the baby presentation. So I'm just going to go to the baby notes now. And whoops, get rid of that. And maybe, oh, there we go. Okay. All right. Okay. So, just down here. Whoops. Okay. Come on. There we go. All right. So pregnancy, human development. It's chapter 29. It's not 29 in your book because it's not, well, you don't even have a book. You have these are from the old book that we used to use. So don't even worry about the chapters. Eventually I'll change them, but just go with our notes. And truly, I have not looked to see what is in the online book, the OpenStax book, as far as this is concerned. So I'll probably take a look at that today. I'll write that in my other notes for today. See what their embryology is like. Oh, you guys, since I took embryology last semester, I would just like to spend the next semester with you, teaching you all about it. I feel bad. We're only going to spend 3 days on it and then we're done. So know that there is so much more, obviously. Okay, so here's our objectives. Whatever. All right. I don't really, at this point, because I'm so tired, we're just getting to the end. Okay, so now when the sperm, okay, so I've told you before that when the sperm are ejaculated, it's like storming the beaches at Normandy. And seriously, it is any battle. It is any historical battle that you can ever think of. That is exactly what's going on between the sperm and the woman's body, because she considers them foreign objects, creatures, just like bacteria or fungus or parasites or anything like that that could invade her body. So she's already got mechanisms to set up to prevent infection by bacteria or viruses or and, you know, any other pathogens. So her sperm, so the sperm, his sperm, need to be able to surmount that opposition and to be able to get through all of the barbed wire and the mustard gas and just everything to get to his ultimate goal. So what's good though is that when the sperm leave the man's body, their fertilizing power is not as great as until after they enter the female body, because those adverse conditions that are in there capacitate the sperm. So what that means is make them capable. They have the capacity to fertilize now. So what does that mean? Remember that you had, I'm just going to draw it. You had, so here was your head and your mid-piece and your tail of your sperm. And then up here at the top, we had that acrosome. So this is the acrosome right here, where the enzymes are, where the hydrolytic enzymes are. Now, up until this point, we've been keeping them really tightly held inside of there, but now we want them to leak out. And so by encountering the acid that's in the vagina and antibodies that can be there and just everything that could try to spoil their advances, then that's going to weaken the acrosomal membrane so that the hydrolytic enzymes will be free to be released when they encounter the ovum. Unfortunately, sperm, you know, so what did we say? 400 million sperm that it takes to get to fertilize an ovum, because we lose so many. The casualty rate is so high that if we only had like 10 sperm, you'd never fertilize the ovum. Those 10 bad stuff would happen to them by the time. You want that herd mentality where the good ones stay in the center and the outside ones sacrifice themselves for the inner ones to get to where they're going. Anytime the sperm encounter a solid substance, they start to fertilize it. So if they were to encounter the wall of the uterus right here, they would just swim up against it, and then the enzymes would leak out. And now he can't go do anything. If he figured out at this point, oh, I'm trying to fertilize something I'm not supposed to, and then go swim, find the egg, he's got nothing to penetrate the outside of the ovum with. So you know, we've got the uterus and we've got the opening. Okay, so the sperm, let's just finish it off. Into there and into there. Okay, so the sperm are coming up here, and then you know, half of them have to go this way and half of them have to go this way, and some of them swim back the other way and swim up here and think they're done, hit the dead end. And some of them don't even, I mean, some of them can be kind of two-headed sperm that didn't separate, you know, meiosis, cytokinesis didn't happen properly. Some of them don't have all the mid-piece and tail that they're supposed to, just, you know, so then there's all these guys that can't even do anything. They're all hanging around down here. So that's why we need so many in order to fertilize the ovum. Okay. All right, so those, the opposition to sperm make them capacitated, given the capacity to fertilize. All right, then we need the acrosomal reaction. So what is that? Now, the little bucket of enzymes that you have in your acrosome are not enough. Okay, so that acrosomal reaction is when we have hundreds of acrosomes there to break down the outside of the cell. So let's take a look. Oops, let's take a look at. Oh, come on. So here's what the sperm have to do. Notice that there's a whole bunch of them, and they're just kind of like digesting away the outside. So so as they digest away the outside, finally one is going to be able to come in and fertilize the ovum. But hundreds before sacrificed themselves creating that opening. So they're, you know, digging the trench or the tunnel into the ovum from the corona radiata and the zona pellucida. So the first sperm, oh, I'm sorry, you guys. The first sperm that gets there is not the one that fertilizes the ovum. Not by any stretch of the imagination. You got to wait for the rest of the guys bringing up the rear before one of those will be able to fertilize the ovum. So the one that finally makes contact with cell membrane receptors has its nucleus pulled into the oocyte cytoplasm. So that's what's going on in this picture is that, and so we're stepwise. This is 1, 2, 3. They maybe came the other direction. I don't know, read left to right, but I guess left to right. So these guys, they're breaking it down, and here the acrosomes breaking down the zona pellucida, and finally the head of the sperm can fuse with receptors that are on the cell membrane here, and then it's gonna, and then endocytosis will happen and will engulf the sperm head, and the rest of the piece will break off, and we don't need that. But we just want we want to be able to engulf that one sperm. Okay, so since we only want one, what about these other guys that are out here? Well, now we need to do what's known as blocks to polyspermy. So we have to prevent fertilization from happening by other sperm. So multiple things have to happen. So the first one, as soon as the cell membranes of the ovum and the sperm make contact, sodium channels open up, the oocyte depolarizes, and the others cannot fuse. So the receptors are just not allowing fusion of the sperm and the ovum to occur, okay, because it closed those channels. So I'm guessing, you know, whatever voltage gated stuff going on is going to prevent then the rest of the sperm from binding. Okay, then the next thing that has to happen is that calcium is released from the endoplasmic reticulum, smooth endoplasmic reticulum, to prepare for the rest of meiosis. And then, and I'll show you this picture here in just a sec, granules deep to the membrane spill enzymes out into the extracellular fluid space to destroy sperm receptors, and other sperm are detached. So all of these things right here, secretory vesicles, cortical granules, that have these enzymes here on the outside. So as soon as they get depolarized and they open up, then these guys can't bind anymore. So they detach and they just get destroyed by the mother's body. I don't know, maybe they fall out. I don't know. I didn't really think about what happens to the rest of the sperm. They just don't do anything. Okay, so that's what has to happen. So now, what are the events that are going to take place once the sperm and the ovum unite? So here we have in this picture, we have the ovum. Now what we need to do, that calcium that was released back there, we need to finish the second meiotic division, because what's going to happen is that when this secondary oocyte was ovulated, it stopped in metaphase 1 or metaphase 2. So it stopped in metaphase of meiosis 2, because it's like, I don't have to do anything. I don't need to make the rest of the polar bodies yet. So I have one polar body here, and then it finished its meiotic division. So that gives me a second polar body here. And then here is the 23 chromosomes that's going to stay in this ovum to unite with the sperm. And then here is that third polar body that's being produced. So now that the sperm has come into the ovum, we're going to get rid of the mid piece and tail, and we're going to keep this, and we just call it the sperm pronucleus. Okay, so here is the 23 chromosomes from the dad, here are the 23 chromosomes from the mom, and then the 3 polar bodies. So now what we want is that the chromosomes for the male and chromosomes from the female are going to line up along the metaphyseal plate, and then they're going to separate out until we get that, let's see, they're not going to separate yet. They're going to come together first and form the zygote. Okay, so now we've got 46 chromosomes here, and now the zygote is going to go through DNA replication. So it's going to replicate all 46 of the chromosomes, and then they're going to line up here in the middle, and then we're going to pull them apart, and we're going to get 2 daughter cells, and we get blastomeres, and then they're going to divide again for 72 hours, and then we'll get we'll get our morula. So this is going to happen within the first 24 hours after fertilization. As it eventually, so here we've got our zygote. So this is official, where the sperm and ovum nuclei interact with one another. The chromosomes all come together and mix around one another, so that dad chromosomes don't always just stay in one cell and mom chromosomes stay in another cell. We want them to all independently assort. Okay, so now let's finish this off with what we learned in lab, and then we'll talk more about this tomorrow and Friday. Okay, so now we've got what's known as pre-embryonic development. So I don't have an embryo until after implantation. So this is just a pre-embryonic organism, group of cells. Has not even differentiated. Oh, I got to do another note. I just remembered I have to. I'll show you this tomorrow. Okay. So cleavage, which is the first, excuse me, mitosis. Oh, let's put that in. Make a little note. Okay, so this is the first mitotic division. Okay, so then there's our 2 identical blastomeres. 72 hours after fertilization, 16-stage morula, so we have that little ball of cells. 4 to 5 days after fertilization, remember that's when we start to see some differentiation, where the cells that were on the outside of the morula are going to stay there and become the trophoblast, and then the cells the rest of the cells are going to clump together to become the inner cell mass, and then leave a fluid-filled hollow cavity called the blastocyst, like my wonder ball. Okay, so let's look at that. All right, so here's the zygote. Here we just divided twice. Here we've divided multiple times. So there's just a solid ball of cells is our morula. Then we have to make it hollow. So the cells that are on the outside, one layer thick, because remember, this is a solid ball. This is like solid bunnies you get at Easter, not those rotten hollow kind, cheap hollow kind. So solid ball of cells. So the cells on the inside are going to be the inner cell mass, and then the cells on the outside will remain to be the trophoblast, and then I get this blastocyst cavity. Notice also that it says degenerating zona pellucida. So let's go back to, well, let's just go to this picture right now. Okay, these cells around the outside, part of the granulosa cells, are the corona radiata. So the radiating crown around it. And then we have the zona pellucida, or this yellow waxy material here on the outside. So you can see the zona pellucida is still present through those first couple of mitotic divisions. And then by the time we get to day 4, the blastocyst, I guess at this point, has outgrown the volume of the zona pellucida. So it has to basically hatch from it. So the zona pellucida degenerates to the point where the blastocyst can now grow outside. And so then by day 6, we have this implanting blastocyst cavity, or implanting blastocyst here with this inner cell mass and the trophoblast. Okay, let's put some days in here so that we get an idea of why whatever happened. You'll understand what I mean in a minute. Why whatever happened. Okay, zygote. So what day is this in the mom? Hello? In the mom's cycle, what day are we on where we have a zygote? Is anybody still there? I'm gonna make you think through this.
Yes, but I don't know.
What?
I said yes, but I don't know. I'm thinking.
Okay. So when did the ovum, on what day did the ovum appear? Before it was fertilized. What day? Come on, you guys. What day does the ovum appear?
Day 14.
Day 14, because what is day 14?
Ovulation day.
And what is ovulation? When
Basically when it gets released.
When what gets released?
The egg.
The ovum. Yes. Can an ovum be fertilized while it's still in an ovary?
No.
No. So do we have to squirt it out of there?
Yes.
Yes. Okay. So we've squirted out the ovum on day 14. How long do ova survive?
24 hours?
24 hours. So if you want to have a zygote, what must happen?
It must be fertilized within that 24 hours.
Exactly. So what day is this?
15?
Yay! 14? Woo! See? I knew you would know this. I knew you guys could figure this out. All right. So this is day 15 in the mom. All right. So what is this day?
17.
Day 17. Good. Okay. What is this day?
18.
Yay. Defay. Day 18. Okay. What is this?
19.
Yay. Whoops. Okay. Day 19. And
21.
yay. Okay. Day 21. So it took us 6 days to be able to what? To get to the point. Implant. Excellent. Okay. So we have to it took us 6 days to get big enough to implant. All right. So where would we want to be doing all of these stages so that we're still safe?
In the fallopian tube.
And the uterine tubes. Perfect. Okay. So that's why fertilization is going to happen way up here at the top, because if it happens down here, by the time you get to day 6, what could happen?
It would just fall right out.
It fall right out of there. Right. Okay. All right. So now let's go through the rest of the day. Oh, well, let's see. How many days do I have left? before mom has a period? When does mom have a period?
28.
Day 29, 28 days, and then on day 29. So what do we have left?
8 days.
Okay, so we have 8 days. So this, okay, so we need right to this point, implant and stay until, where's my thing? Oh, I'm looking for the wrong thing. Okay, so we can give it until, so day, well, here's what I want. How old? So by day 29, how old, or day 1, how old will this blastocyst be?
Didn't you already say 28? Is it 28 days or 29?
No, how old is the blastocyst?
Oh, 6 days?
Nope, because it took, no. I said by the time we get to day 1.
Oh, isn't it 14?
Yes. Okay, so this baby is 14 days old. Okay. It has to get to 14 days old. Now, why do I ask that? I'm going to show you that. Let me, what's my, okay. So Ella, you're right. All right. Okay, so, so once it implants, it has 8 more days to do something. And then by that time, it's going to be 14 days old when the mom should have her period. Okay, so keep that in mind. She should have a period when this baby is 14 days old. All right. So why do we care? Because we're going to look at that right now. Do I have time left? Oh, I don't. Okay. What a great place to stop. What's going, actually, it is a really good place to stop. I'm just going to fast forward to, okay, to this little point right here. Okay, so here the blastocyst is, so that you can think about things when we come back. Okay, 7.5 days here, old. This is 9 days old. This is 16 days old. So where do we want the embryo? What stage, how far along in development do we need that embryo to be by day 1 again? Okay, so this is what we're going to leave it for today, is how far along does the embryo need to be before she has her period? So that's what I was after, but this little picture will help you. Okay, so we're going to start then when we come back tomorrow. We'll start here on implantation, and we'll go from there. So does anybody have any questions before we leave?
So what happens if you have like a late implantation to where the baby isn't as far along? Or will it always be that
we'll talk
far
about
along?
that. We'll talk about that tomorrow.
Okay.
Yeah. So no worries really. And we'll talk about why tomorrow. So remember that question. Well, I'll remember that. I'll remember we said that. Okay. So that's it. If I don't have any other questions. Oh, I wanted to let you know that I am starting to grade the test 5. So I'll be trying to get that done today. And then remember, you have your lab practical that you need to finish up today. And then test 6 will be, so I'm going to open up test 6 on Friday. So then you'll have Friday, Saturday, Sunday, Monday to get it done. And then, and we'll go from there. So, okay. See you tomorrow. Bye. Is your practical going to be mostly pictures? Yeah, mostly, not entirely. We'll put it like that, because remember, you do have PhysioX questions that are going to be on there. So, okay. All right. So there you go. Oh, I am still recording. What the heck?